So, ladies and gentlemen, let's start off with one of the first sessions. Like I said in the beginning, we have 4 in total, and we're going to start it off now with artificial intelligence. Yes, artificial intelligence, with the title Earth System Predictability, How Space Data and AI Can Advance Planetary Stewardship. So we're going to dive into this first panel, a discussion on AI, covering its definition, its distinctions from simulation, and also versatile applications in space and beyond. We're going to explore its impact on urban planning, on climate change, natural disaster detection, prediction, and resource management. And this panel will also address challenges emphasizing the need for data to benefit local communities. We'll also discuss the cost and necessity of AI compared to other models and ponder on the question of regulation. What I'm going to do now is I'm going to introduce our panelists, and then we're going to start it off. So let's bring up our first panelist and also moderator, Mr. Alessandro GRASSO. Welcome, Alessandro. Now, he is the moderator of this panel, but he's also an aerospace engineer and current head of Earth observation at the Luxembourg Space Agency, serving as the Luxembourgish delegate to the ESA Program Board and the European Commission Copernicus Space Program Committee. He brings over a decade of experience from managing significant European space projects with OHB and Airbus Defence and Space, and additionally, he holds the position of chair at the ESA Dostag. Alessandro, was that correct?
Very much correct.
Very much correct. Looking forward to having you on the panel. Please take a seat.
Welcome.
Also joining us, ladies and gentlemen, please give a big round of applause to Mr. James PARR. James PARR is an inventor and entrepreneur who spent his career tackling grand challenges, from planetary defense, fighting floods and wildfires, obesity, violent extremism, and cancer, exploring the moon, clean energy, understanding space weather, and mitigating the effects of climate change. He is founder and director of the Frontier Development Lab in partnership with NASA and LSA and ESA in Europe, and leaders in commercial AI, such as Google Cloud and NVIDIA. He is also CEO of Trillium Technologies, an AI company dedicated to building a more intelligent future. James, is there anything I forgot?
Just to watch the step.
Just to watch the step. All right, but you found your seat. Welcome to the panel. Thank you very much for joining us here today. Also joining us, please welcome on stage Mr. FILIPE PAIS. Filipe, welcome to the stage. As Chief Customer Officer at Luxprovide, he drives innovation in technology. And with 2 decades of experience, he played key roles at major tech companies like Amazon Web Services, Microsoft, and SAP, contributing to the democratization of big data, analytics, and artificial intelligence while accelerating digital transformation across Western Europe. Filipe, how are you feeling today?
Fine, thank you.
Fine, thumbs up. Why don't you have a seat? Welcome to the board. And one more, our 4th panelist. Please welcome NICOLAS MAILLOT. Our 4th panelist, the leads edge AI development for future environmental and defense programs at Thales Alenia Space, drawing from nearly 2 decades of experience. Previously, he spent a decade at Amadeus, where he played a key role in developing large-scale machine learning and analytics applications for flight search optimization. He holds a PhD in computer vision from INRIA Sophia Antipolis in France. Welcome to the stage, and why don't you take a seat? So, that sounded like your microphone's definitely on, that's for sure. All right, maybe we'll get him a different microphone before we all go home with the tinnitus. There we go. All right, technicians on the way. Ground control, ground control. All right, so first off, let's check the other mics. You guys, you're fine, right?
Oh, fine.
Test. Working here.
Working there, all right. And now, the question is, will we get his to work? But I think so. yeah, maybe we'll just get it started. Why don't you start it off, Alessandro, as the moderator, and we'll find our way with the mic.
Yeah, absolutely, and thank you for this introduction. It's such a pleasure to be here with you today to discuss such an amazing topic, which is AI and its intersection with space and how it can also help us down here on Earth. So we have all heard about AI, right? In the last few months, it's been quite a buzzword, especially thanks to ChatGPT. Who hasn't played with ChatGPT? Well, James maybe hasn't, no. But so maybe let's take a step back, right? So what is AI, in your opinion? James, maybe you want to start.
Oh, golly, you start with the hard ones. I mean, I think it's the paradigm shift really is we now have the ability for machines to learn, and that's really what AI, that's the change which is happening. But AI has been around for 50 years. It's been around as long as the space industry. In fact, the summer of 1957, around the time of Sputnik was when AI was conceived. So it's taken 50 years really to get to a level of maturity. But the big change was in 2012, and they call it the deep learning Big Bang. And this is when deep learning really came to pass, and this was the ability to train AIs with lots of data. And this has coincided with the era of big data. Remember that? We used to say big data a few years ago. Well, now, of course, our machines can understand that data, and that's really the revolution that's happening now.
All right. Felipe, maybe you'd like to add something?
Yeah, so AI is a way of putting process to mimic human intelligence. So basically, you have models that will try to replicate what the brain of a human will do when you have some challenges. So decision-making, analyzing data or analyzing words and sentences. I think that the big shift that we have on AI in the last couple of years was not the technique, was the capacity to run the models. So like James was saying, since 25 years that we have AI models running, but we didn't have the capacity, and I'm talking about infrastructures, that will help us to do what we are doing today. And with the advance of the technology and the hardware, today we can do the things like ChatGPT, but ChatGPT is one technique that you have on AI to bring us the results that we are seeing today.
Thank you. So I'm hearing data, infrastructure. Nicolas, anything you would like to add as well?
Yeah, maybe one complement to what has been said. So yeah, that's true. AI is about, let's say, reproducing human intelligence. And it can also, not only human intelligence, animals, for example, a cat, a dog, has a very, very interesting forms of intelligence, which we are not able to reproduce today in AI systems. So there is still a lot of work to develop in that area, in robotics in particular. So plenty of things to do. Space robotics is one application where AI can bring a lot of value, autonomy, etc. So plenty of things to do for the future.
Thank you. And that brings us then to the next question, which is, you introduced it, one of the applications of AI, for example, robotics. So what can we use AI for? And also, what is the intersection between AI and space? And also, how this will help us here on Earth?
Yeah, I mean, I think it's useful to think about case studies, use cases, and I think wildfire fighting is a really good, powerful example of the use of AI. And so you can think about wildfire, this huge problem we now have, if you think about the fires in Canada and, in fact, raging all over the world. But we can use AI for prediction, for understanding how the conditions are changing, and of course use space data for that prediction. We could also understand ignition points, and so use infrared data from space, and the AI can then see those ignition points. And then once we have that ignition point, we can map and understand how the wind and the fuel will change the progression of that fire, and then provide information for emergency services, emergency responders to respond in time. And so there's lots of AI technologies just through that chain from prediction to action, where AI is a powerful toolbox. And I mean, I think we talked about ChatGPT. Large language models are going to be crucial for that last step in the chain, which is providing just-in-time, localized insight for decision makers, when they need the information, and that's now, now possible. So it's a really exciting time.
Right. Yeah. Nicolas, maybe you want to add?
Yes, there are plenty of applications of AI in the space industry. Of course, AI is a very, very powerful tool and to explore the huge amount of data that is produced, for example, by the Copernicus satellites. We know that we use a fraction of the data. AI can help to explore them more efficiently, to sort the information, to combine different data sources. So AI is very strong at this and to support the scientists and people who are not specialists in AI to actually achieve more in the end. So this is very important. There are also applications of AI that are not so intuitive. It's a lot about imagery, etc. But it is also, for example, about mission planning and mission optimization. When you have a constellation of satellites, be it for observation, telecommunication, there are complex problems to optimize the configuration of the constellation so that it is more efficient. And here again, AI can bring new solutions, new approaches to optimize the performance.
Thank you. And Philippe, from a supercomputing perspective.
Well, I would also add here something that is about AI and simulations because, for example, Chris talked in the beginning. And so there is a lot. So first of all, simulations is more a way of putting models to replicate real-world systems or phenomena. And I believe that joining AI with simulations can bring us a lot of benefits. So, and giving you a use case of an example that you use also space data for that. So we use space data, for example, for simulate floods. Simulating floods is about physics and understanding the fluid mechanisms or the water spreading around. But if you put AI on top of it, you can probably, understanding how it will impact and work on, for example, on evacuation plans. So putting the intelligence on top of the simulation can bring you additional results of what you are doing today and using space data, for example.
That's really interesting. So we've talked about wildfire, flooding, and putting everything together. So what is the next step? Can we put everything together and simulate and then predict, thanks to AI, what's going to happen in the next 10, 20 years in some sort of big modeling? James, what do you think?
Yeah, I mean, I think, the title of this panel is Earth System Predictability, and really that's the vision that's happening. We had a sort of revolution in weather forecasting. If you remember, only 10 years ago, it was pretty hard to get an accurate weather forecast 3 days in advance. We now are used to this. AI can extend that to 10 days, and we've seen this with Google DeepMind recently. But not only doing this on the supercomputer, this can now be done locally. So AI's got this incredible ability to speed up our simulations, and there's a number of these new weather forecasting tools which are coming online. Now, extend that to the whole planet. So we're seeing this sort of little glimmer of what's possible, but now we can start thinking about, well, what about every system that makes our planet work? And so, for example, I've seen recently someone using these methods for simulating ocean currents, and you might say, well, why is that useful? Well, the computational task of simulating ocean currents was beyond us until now, but now we can do this and give it to shipping industries, and so the tailored current predictions can be given to captains of ships, and they can make more efficient paths on their journey across the oceans. So that's a very concrete example of how simulation, AI-driven simulation, is turning into intelligence, which is informing decisions which are potentially beneficial for climate. So imagine that on a sort of global scale. That's the sort of vision that we're talking, that we sort of is at our fingertips, and we've been calling this a nervous system for planet Earth. So we'll let the big players like OpenAI and Microsoft and Google build AGI, if you believe in that. But I think the opportunity for the space business is to build the nervous system that connects to that intelligence.
Right, thank you. And Philippe, so we've heard now a lot of very interesting facts about how we can predict the future. Do you feel in a way threatened by AI in terms of supercomputing, or can you work hand in hand?
Well, first of all, I would like also to add something of what James was saying. So AI can definitely be used with space data, for example, from climate change mitigation, which is a hot topic today, where everybody talks about climate changes. And basically, we can use all this capacity, not only from the infrastructure on our side, but also the data that comes from space, and using AI and digital twins exactly to understanding what could be the impact on Earth and taking some measures on it. And for example, from our side, we are working with the European Commission and ESA and LSA on a big project at European level that aims Destination Earth, which aim exactly that. So the goal of this project is to create a digital twin of Earth, for example, for oceans, but also for climate. And with that, using space data and AI exactly to understand what will be the impacts of climate changes in the Earth, and probably try to find what kind of solutions we can put in place for that.
Okay, and so to the second part of the question, do you feel as for supercomputing HPC, do you feel AI is a threat or an opportunity? Can you work hand in hand? Do you think it will replace, in a way, supercomputing?
No, so basically I think that they complement each other. So AI needs compute capacity. The supercomputing provides this capacity. So more and more we see that the demand and large language models like the ChatGPT, which takes a lot of compute capacity, are basically using all the capacity that we have available today. And I heard some stories that, for example, Microsoft, when they are training the ChatGPT, they close the capacity that they have for a number of consumers and only for training it. So no, supercomputing is definitely something that couples with AI, and basically together it will provide us what we expect from it.
All right, that's great to hear. And maybe, Nicolas, you would like to add something?
There is a very interesting area of development for AI, which is inside the satellites and in the spacecraft, onboard artificial intelligence, which is a big topic which will continue to grow very significantly. We have seen in the recent years, let's say the past 5 years, an absolutely amazing increase of computing power available that you can put on a satellite, and this is really, really recent, and it opens a lot of possibilities. The applications are, of course, reactivity. You can decide faster about, let's say, an emergency situation for an environmental disaster, for example. So this is very useful with concrete applications. You can have more autonomy, for example, for debris avoidance, which is an increasing concern, as we know. So big field of development on which I spend a lot of time to work on. So many things will come in the coming years.
That's amazing. So you're actually saying, putting AI in a spacecraft on edge AI and then doing the processing on the spacecraft directly, right?
Yeah, absolutely. And which is even more interesting is a combination of what has been said about HPC, cloud computing, and onboard intelligence. The combination of all this, we can call it edge computing in a way, and it opens a totally new way to design space systems. And that's we are not there yet, but a lot of work to be done there, and the applications are great. We are working with Microsoft on this, with ESA as well, with the Imagini challenge. There is a challenge which has been opened in the past few months. We have Thales has built Alenia Space has built, let's say, the payload, which will be put on board of the International Space Station. Microsoft has developed a wonderful space software development kit, and it is connected to the Azure cloud. So we have all the chain put together, and many teams around the world are contributing to that, and we will load the application somewhere probably next year. Yeah, so very exciting.
Super exciting, I'm sure. And so maybe let's stay a bit with you, Nicolas. Right, you represent Thales, Alenia Space, so a big company. How do you decide when AI is actually useful or not? Is it really useful for everything, or do you have some time to trade between AI or a different technology?
Yeah, that's a very good question. I often say, if AI is a solution, what is the problem? So, of course, we need to identify a use case, a problem that can be solved or, let's say, improved by artificial intelligence or machine learning or related approaches. We use AI more and more, for example, on the manufacturing process to improve test management of the spacecraft. When you need a lot of reliability, you can do thousands and thousands of tests, but you can also optimize them in a better way thanks to AI and getting the data from the satellite, put them on the ground, analyze them, and improve the way we test our spacecraft. So that's interesting new use cases. That's more related to analytics probably, but AI can bring a lot here as well.
Yeah, thank you, Nicolas. And James, do you agree that AI is really useful for everything, and we really need to invest in it?
It's a good question. I think the thing about AI is not perfect. And it's really important to remember that. And it never will be. And so you have to be really thoughtful about the scenarios where it's deployed. But for example, looking at evidence of metastasis in lung scans or the potential for diabetes in retina scans, once it's trained, it can do a much better job than just a layperson, a normal person, but it won't do as good a job as a specialist in that problem. And so you could think, well, what's the scenario where that would be useful? Perhaps it's useful in the developing world as a sort of triage task. It could sit on a device and it could say, well, potentially there's a case of diabetes or a potential cancer situation, but you couldn't replace a doctor in that scenario. And that's true of everything from self-driving cars to piloting rockets. You need to think about kind of what is a situation where a kind of mundane task or a scale task can be replaced, but you still have to have a human in the loop. And what we found with some of the work we did with ESA was that we could replace or use AIs to scale the capabilities of human experts, but we still needed the experts to make the final decision. This is for ground station pass management. And so we could actually learn from the best of the best and get the AIs to do that, scale their capabilities, but we didn't replace them. And so it's really important to sort of have that mindset, like it's not a tool for replacing human beings, but it's a tool for scaling our capabilities.
All right, thank you, James. And in a way, I think that is reassuring. I think Nicolas here wants to intervene.
Yeah, maybe one additional comment on this. So James is totally right, and to say that AI is not perfect, and it can fail. And we have all used ChatGPT. Sometimes it hallucinates, and it's true also for other types of artificial intelligence. So the question is, how do we handle that? We know that the space industry is really risk adverse. Historically, it has always been like that, and it's like this. So we need to think on how to integrate those AI techniques in a way that does not impact too much the missions, and that's a challenge. There is also a cultural shift here to operate.
Thank you. And Philippe?
I want to add also something that is, well, I would love that everybody uses AI on everything and supercomputing. I would appreciate it, will help me and my business. But I think that AI, well, will not solve everything. So like James said, I totally agree with that, it scales. So when you need to scale and you need to have decision-making on process that you need to repeat and optimize, it scales. But in the end, the final decision, when we are talking about critical decisions, needs to be the human decision, because AI fails, and AI fails a lot of time. It depends also, it's related with the model that you use, the data that you ingest, and so there is a lot of biased results that come from AI models. So like I said, AI is good to reduce the time of human investment on several tasks, but we'll never replace humans, at least for today.
Right.
Well, can I add a...
Of course.
So this is, I think, there's lots of debate about the big dilemmas of our time and AGI, artificial general intelligence. But actually, I think what's sort of fascinating about the era we're now in is AI can take in data sets beyond our senses. So we have a million senses. You might argue that we have 5 or 6 senses if you count balance as a 6th sense. But an AI can take on data from the whole planet and all of the infrastructure that we have built in space. And so in some instances, it has more evidence, if you like, to base its decisions. And not only that, it can do it in milliseconds. Instead of taking months, it can do it very rapidly. And so with this proviso that it may not be perfect, a lot of those questions may be good enough. And so, and it's a little bit like the problem or the dilemma posed by Elon Musk about self-driving cars. If you have enough self-driving cars on the road, the actual death toll will go down. However, that the few fatalities, obviously that's a huge issue. But it's just a little bit like managing a planet. Like we could have trillions of good enough decisions to avoid the worst effects of climate change that we let an AI conduct for us. But the question is, are we comfortable with that? Are we comfortable with good enough as opposed to perfect? And that's the dilemma I think we need to sort of think about as a group, as a species over the next few decades.
That's a very challenging dilemma, I think. Yeah. And so, in your opinion, do we need to regulate AI?
Well, definitely, like I said previously. So, first of all, there is a lot of models that brings biased decisions exactly because the data that you ingest could be not the right one, and it could lead, to decisions and influence a lot of people to take wrong attitudes. So that is one of the things. So we need to have regulations not only on the type of models, the variables that you use, but also the type of data that you use, but also how you implement these tools to make decisions. So like I was saying previously, it's definitely a tool that will help human people to scale and to take decisions and helping to take decisions, but we need definitely to have regulations on how we use that tool in different aspects.
Thank you. Nicolas?
Yeah, maybe some thought about this question, which is very broad, actually. I think we need to be specific on which type of AI, on which type of system it is actually embedded. For example, if you think about medical devices, where people's lives is potentially at risk if AI takes a bad decision, the same for defense systems. Here, clearly, there is a need to have some human in the loop, and there is no doubt about this, some validation before taking any critical decision. So this one is for me, totally clear. Regarding AI research in particular, there is a debate here probably to have, should we regulate it or not, as long as it is open, thanks to open source. I strongly believe in the power of open sourcing AI technology. Yann Lequin from Meta is pushing a lot in that direction, and I think this is the right way to go. Open source is the key. As long as it is open, that other people can take the technology, adapt it to their needs, it can be okay. So here, and another thing that we need to think about, it is very difficult to regulate such a thing. AI, like the internet, is a very complex system. ChatGPT and large language models will be spread over the internet in the coming years everywhere. So how do you regulate that? Honestly, I don't know. You can block them, maybe, in some cases. You can maybe try to spot them in some cases, but it will be more and more difficult. So we need to be more specific in the regulation and ask very precise questions.
All right, so I'm hearing there should be some regulation, but it's not so simple. It's not black and white. What do you think, James?
Yeah, it's interesting because you have a sort of spectrum of fear, if you like, and you have Facebook's or Meta's Yann LeCun, who he said AI's not even as smart as a cat, although cats can be pretty smart. But and then Jeff Hinton, who really one of the fathers of, well, they're both certainly progenitors of AI, and he's been very worried. And there's everybody in between. I think for me, the thing which really frightens me is fake data. So the ability for language models to create very, very plausible data which actually can only be assessed by an expert. And even then, there's so much of it, and it gets mixed with other data sources, and then we basically have a breakdown in trust. And this is what Noah Harari, I think, has been very articulate on, about the problem with our civilization is that trust is a key mechanism of our institutions. And if trust breaks down, then we really have a problem. And so I think AI as certainly this situation where synthetic data is being created and integrated into our data sources, this is something we need to be really careful about, because if we lose trust, we lose everything.
All right. So I'm hearing AI is not so simple to handle, and it also requires, you said before, Philippe, a lot of computing costs, right? And you need programmers, you need the codes. So it's not such a simple technology. So is it really for everybody on Earth? Can it really help the whole Earth?
Well, I think that is for everybody. The problem is the access to that. So in developing countries like Luxembourg and the majority of European countries, you have not only ways of assessing data, like, for example, space data with the Copernicus program, and you have also the resources to work on this data. So you have HPC centers like the one that we have in Luxembourg. We have a lot of research institutes like the one that we have in Luxembourg, and you have expertise. So assessing and working on the data and using AI for that is easy for a developing country like Luxembourg or other neighbor countries that we have here. But we have a lot of countries under development that don't have access to this data. Neither they have resources for doing it. So while I think that everybody needs to have access to that, because you can basically create innovation and accelerate digital transformation and have good impact on the economy. The problem is not everybody have the same access for that. So it's about also having money and capacity to do it.
Thank you, Nicolas.
Clearly AI can be done anywhere in the world. And you can do significantly useful AI on a simple, powerful laptop. This is one thing. But what we need to be aware of is that a very, very few number of factors, companies have the, let's say, computing infrastructure which is large enough to emulate the number of neurons that we have in the brain. Probably there is Microsoft, Google, and a couple of others, maybe some governments. But it is very, very limited. And we can suspect that with such a computing power, there will be a superiority in the AI capabilities that only a few actors will have. So that's a bit worrying.
All right, so it's a worrying subject that we need to be careful with it, I think, as we develop. And so let's come back now to the space topic, AI and space. Do you believe that space as a sector, I'm talking here about upstream and downstream, can space be a trailblazer for AI, or are we just a follower? Do we just implement technologies that are developed elsewhere, or can we actually be trailblazers? Who would like to start?
Well, I can give you an example about using, but definitely my colleagues must have more than me. But you know, today space could be definitely a player on AI, because a lot of the data that comes from space can be used to have impact on space operations, but also outside of space. So giving you an example, so using space images, you can, for example, implement AI for resources management. So for example, on the areas of agriculture, so for crop yield optimization, or you can, like I was saying first, you know, implementing AI for disaster prevention and mitigation. So definitely the space is in the forefront of the run to using his own data and using AI, not only to create benefits for the sector, but for other sectors.
It's very interesting. Nicolas?
Some thoughts about this, yeah. So I think it depends on the type of AI you are talking about. I think the space sector can be really leading in robotics, for example. There is a lot of things to do. Intersection of robotics, machine learning, AI, etc. Here the space sector can be really, let's say, pushing the envelope. In other sectors, like large language model, we need probably to be follower, integrated that smartly with remote sensing images on our own problems, let's say, but I don't think we can lead in every topic.
Thank you. James, what do you think?
Yeah, I mean, if you'd asked me a year ago what was the biggest thing in AI, I wouldn't have said LLMs. I would have said physics-informed learning or neural operators, and I think this is where actually space, space for science, AI for science, sorry, can be a leader. And in fact, work we've done with Luxembourg has shown the power of this, sort of using AI to look at the craters in the south pole of the moon. And this is physics-informed learning, so extracting understanding of physical features using AI. So I think that's absolutely a place where space can take the lead, and already is actually. So yeah, I think space is well poised.
Thank you, and that is really encouraging. Yes, Nicolas, you would like to add something?
Complement on this, behind this question, there is the question of access to AI talent. As we know, there is a huge demand for this type of people. How the space sectors can attract those people, so that's a topic to be attractive. Gives those people the right infrastructure, the right tools, the right way to work, etc. So that's something we need to think about.
Thank you a lot for your contribution. Now, do we have time for questions from the audience? We do, yes. We have the green light. So don't be shy. We have a panel of experts here with us. Any questions from the audience? The floor is open.
This is your chance. There we go. Question right over here. Would you come up front, or we can hand you the mic, though, too? Yeah, it's easier. Perfect. I'm at the perfect sound, too. Thank you.
Hi, everybody. Edgar Milic. I'm first and foremost a space passionate and a professional of the sector. As a kid, I was starting on science and space with Isaac Asimov. And one of the key elements of his stories were that there is great potential in AI, and robots in that case, but there is also very high threats. In that case, the solution was to ingrain in the AI algorithms some specific rules that were permitting the robots and the AI not to hurt humankind or people. do you think that beyond regulation, do you think AI will need these kind of measures, like some hard-coded elements of any machine learning and AI architecture which prevents them to hurt?
Maybe I can take this one. We integrate. I speak for Thales Alenia Space. Thales globally is let's say integrating sophisticated software, including AI, into critical systems. And I can tell you that we take a lot of care about AI safety, software safety. There are tons of tests, etc. And of course, there are hard-coded rules that can shut down anything that could take a bad decision. There is, let's say, we follow the state of the art about AI validation, etc. There are some works done with ESA on those topics. So yes, the answer to your question is yes, clearly.
I would probably also add here something, because this is a great question, and probably there is no yes or a no. Because in my opinion, if you condition development, you are basically putting some blockers on doing more things. But also you have the threats or the risks, like you are mentioning, that not conditioning the development of the software could also bring to other kinds of impacts. So I think that I don't have a no or yes question to you. I believe that you need to find an alternative way to do it.
Yeah, I think, as I said, no AI is perfect. And I think that if you have that as your sort of operating concept, then of course you need to have sort of mechanisms like is it the 3 laws or the 4 laws? I can't remember. But I think one of the things which is useful to think about is the idea of AIs working as an ensemble of AIs that can check each other's work, if you like. And so if, this sort of scenario that people are talking about in AI, particularly, making an error, in that millisecond, another AI can go, wait a second, I'm going to check your work and there's something wrong here, and perhaps we'll ignore that output. So I think there are engineering solutions that we can put in place as we architect our systems to make sure they're as safe as possible.
All right, thank you very much for that question.
Over there.
Would you like to add something? Here's another question in the back. Yes. So, would you mind stepping up front here? Sorry, so that we can, and also our remote audience can hear you and can hear the question. That's very important. By the way, to our remote audience, you can also just ask your questions via the chat. There's a chat function online. Please use that. All right.
Yeah, I just wanted to have a short comment. I think engineering hardware solution is the issue here, because don't get me wrong, I'm not critical about AI. I'm a lawyer, and believe it or not, legal work is pretty close to what AI does. It's data analysis. And believe me, there is no rule a lawyer can find a way around. And if you rely on software rules, AI, if it develops further, will be always able to get around it. So I would just like a switch-off knob to be built in, a hardware.
What do you think? Can we have a switch-off button?
Yeah, sure. This is a human in the loop, and there needs to be a button somewhere. In any case, yes.
So we always need a human in the loop.
I mean, in the case of hardware systems, here it's quite easy, because you control let's say, the box in which the hardware is and the software is hosted. So it has a limited, let's say, perimeter. The situation is quite different with ChatGPT that we could imagine spread it over the web, the internet, and put a lot of misinformation on the web. Here on the button, nobody knows where it is. It's slightly different.
All right. James, would you like to add?
No, I think an off switch seems like a good idea. Yeah.
Well, I think it's a good idea, but today with all the spread of infrastructures that we have today, basically the majority of the softwares don't run only on one premise, they run in global networks. So unless if you cut all the global networks, or probably you cut the energy everywhere, it will be very difficult to do it, but I think we need to find probably a solution for that.
All right.
All right, one more. Okay, quick question and quick answer.
Hi, I also had a comment on the off button, because AI can be so pathological. If you code the algorithm in a certain way, it will overrule the off button. I mean, this is what I think, because if you code it to, say, print paper clips, it'll take all the resources of the planet and print as many paper clips. So I think a coding which involves deferring to the human for very important tasks is more essential than the off button, because I worry it'll just overrule it.
Thank you.
So can we have something more than an off button?
Yeah, and coming back to what James was saying, so having AI models controlling other AI models. So basically having here some kind of a controlling system in order to avoid that only one gets the capacity to take the decision. So having some kind of a looping decision with models controlling other models, that could be an option.
Yeah, I mean, I think, you know, to sort of take the heat off the discussion, if your mental model is HAL from 2001: A Space Odyssey, then perhaps, you know, that is something to worry about, because HAL, it was the alignment problem. He had two different, if you remember in the film, two different instructions, and that caused a problem. And Kubrick and Clarke were very prescient in that movie. However, you know, the way we think about expert systems is an ensemble of narrow AIs working in concert. And so as soon as you start thinking about that, then the worry's less, because as we sort of saying, you just have, if one gets sort of out of whack because it's ingesting bad data, and that may happen, then the other ones can say, wait a second, we think this is erroneous, and so we'll forget that one for the moment. And
right.
That's a more comfortable way of thinking about this. So the idea of the sort of monolithic AI getting out of control just doesn't seem credible in terms of the systems we're building.
Now, I'm going to have to press the off button for this panel, unfortunately. I see many more questions, obviously, but I'm pretty sure our panelists will be willing to answer your questions, maybe also off stage. So feel free to approach them afterwards. But let's give them a big round of applause here. First of all, on stage, Alessandro, James, Filipe, and also Nicolas. Thank you for joining us, and enjoy the rest of the conference.
Thank you.
Thank you.